One.
All right, so now we're going to start getting a little bit more complicated and start coding for multiple lights. Okay, eventually what we're going to have is 8 lights and they're going to display an image. So let's say this is what our image is. It's going to say hello. We're going to have different colors and happy face at the end, whatever. And so if you look at this image, you can see it's basically pixel art, and there's only 8 squares this way, and then it goes 64. Okay, and so each one of these rows is going to be created by each of the lights. Okay, right now we only have 2, but imagine that eventually we know we're going to have 8 lights. And so we're writing this code so that we're baby stepping our way up to that. So keep in mind as we're creating things that this is what we're eventually going to be doing. All right. Okay, so what we're going to do first is create another array. And this array will have all the lights listed, the 8 lights. And who knows, maybe I might make more lights than that. So we're going to create a constant integer. Oops. Constant right there. Okay. And so what this is going to be is how many lights you have. So we want to make sure no matter how many lights we put in there, maybe someday we will put 30 in there, we'll make a giant display. But for now, we want to be able to change it. And so we'll call this the number of rows. So n and then rows. Okay, so n rows right now is 2. Okay, because we have 2 lights. Each light takes care of rows, and columns are up and down. So each time they blink, they create a whole new column. All right, now, so that will help us in this square bracket right here. Like we used number of colors, we're going to have number of rows. And so we'll now make the array. And I cannot constant and then integer. Okay. And we'll call this one row pin. Okay. Because we have different rows and they have different pins on the Arduino. So each pin controls a different LED. So we're going to give each LED a number, and we'll just like a computer, we'll start out with 0 and then 1. So the light right here, we'll call it 0, and this one we'll call 1, and it just happens to be those are the pins that we're using. So row pin, and then we have to tell it n rows to let it know how many positions are in this array, which will be how many lights we have in the array. Okay, so now we use our curly, and we say, okay, we have 1 and 0, and we have 1 and 1. Close curly, semicolon. All right, so just like we did the array up here for the number of colors, now we have how many LEDs. And then later on, when we upgrade our display to have more and more lights, all we have to do is just add them in here, change this number right here, boom, done. Because we're going to be using this n rows later on in our program, it'll make it so all we have to do to upgrade to more lights is change these 2 lines of code, and that's about it. Okay, now we're going to come down here and add some more functions. Okay, we're going to have to be able to turn these on and off. All right, now we're using analog write for the colors. Now all we have to do is use a digital write for these to just turn them on and off, either on or off. We'll control the intensities of color using 9, 10, and 11, and then just either let the color through LED 0 or LED 1. And we only do one at a time, okay? All right, so we're going to give it a function. We'll say void, just like we always do. And we'll call this one LED on. So to turn on an LED. And we're gonna have to tell it which one. So we'll have an integer and we'll call it row, because it'll be which row do we want, 0 or 1 to turn on. And then semicolon, curly bracket, come down, it automatically does the other one for you. Now, what we're going to do to turn them on and off is use actually pin mode. Now, pin mode is we use in setup to tell it whether it's an input or an output. What we're going to do is use output to turn it on. Just think of output as outputting light. So if we are, and that's not actually what it's doing, but it helps it keep it straight in my mind. So if you want to output some light, we're going to make it an output. Okay, so all I have to do is say pin mode, like that. And we're going to use that array up at the top that we made. What did we call it? We called it row pin. So we're going to look in row pin and go to the proper row. So if we say LED on 0, then it'll do this pin mode thing. So we don't have to say pin mode. All we have to do is say LED on. Just for teaching it vocabulary here. All right, so row pin row, close that up with a square, and then comma, and then say output. It should change color just like that. Okay, close parenthesis and semicolon, and that's it. So instead of having to say pin mode 0 output, all we have to do is say LED on 0. So we're saving some typing time in the long run here. So there's that one. And now we're going to make another one. We're going to have to tell it how to turn an LED off. Okay, so LED off. Basically, same thing. We're going to give it an int, call it row. All right. Okay, so everything's the same there, except for LED off. Now, curly bracket, and down, types the other one for you. Now to turn it off, all we have to do is basically the same thing. We'll cheat here a little bit. This time, make that a in. Okay, so LED on, you make this an output, and if you make it an input, it turns it off because it's expecting something else. Okay, anyway, all right, so that's pretty simple, easy to do. Let me look at my notes here. Okay, all right, now after void setup, let's stick some stuff in here. All right, this is going to seem weird, but it is necessary. All right, back to pulse width modulation. Pulse width modulation, again, is turning it on and off real fast. And we already had that discussion, so I don't want to get into it too deep. But basically what's happening, as soon as we add more than one light, when it's flickering the light on and off real fast, and you go from one light to the other real fast, and you're going between the lights, the natural pulse width modulation that's built into your Arduino isn't flickering it on and off fast enough for me to go from one light to the next. So we have to increase the frequency of the pulse width modulation. And there's a really weird code to do that, so just follow along. I'll tell you what it does after we're done here. Okay, so TCCR, all caps, TCCR, then 1B, all cap, all right? Space equals, then do that same thing again, TCCR 1B, and do the and, it's above the 7, okay, so shift and 7, and then go capital B, and then 1, 1, 1, 1, 1, so 5 ones, and then 3 zeros. Space. Now do the button above the enter, but use shift. Okay, it'll look like 2 lines, but when you put it in Arduino, it just makes it one giant line. So right above your enter key, but shift. It's like the backslash. Okay, and then do capital letter B, then go 0, 0, 0, 0, 0, 0, 0, 1. 7 zeros and a 1. Then do a semicolon. Okay, so there's that one. And then what I'll do is I'll copy paste this down, and all you have to do is change the number 1 to a number 2 on both of these. Okay, so what do these crazy codes do? Well, what it does is it takes the pulse width modulation and basically makes it flicker it on and off 64 times faster than it was before. It was already fast as it was. The way it was before, I would say it could do all the flickers that it needed every 2 milliseconds, but we're going to be going back and forth every 1 millisecond. So it would mess up our colors. So making it 64 times faster, it'll at least be able to flicker it on and off a couple of times before I go to the next light. All right, so this thing is going, we're going to crank this up to full speed basically. All right, if you look at the Arduino right here on this chip right here, this is 16,000. The clock on the Arduino is 16 megahertz, okay? And it takes that and divides it by 255 and stuff to get. And then by 64, we just got rid of the 64 by entering this code. Okay, sorry, I keep getting interrupted. I have to keep pausing it. All right, now, a couple more things. Okay, after that, so what did this do right here? This was the pin mode to activate the colors. So right below that, let's activate our pins for controlling the LEDs, okay? All right, and we can use a for loop for this as well. So for, and then int I equals 0, because we're going to start with the first LED and work our way down. And because we don't know how many LEDs we're going to have, we're not going to put in a number here. We're going to use the variable that we created. So I less than n rows. Okay. Oops. Okay. I less than n rows, just like that. Okay. And do a semicolon. And so when we add more lights, it will help, it'll fix this code so we don't have to change this code once we write it using this method. That's why we do it this way. Okay. I++, and close it up, open curly, and enter. So now let's write the code. All right, so pin mode. Say pin mode, and then you're going to say row pin. So kind of like turning it on. Row pin, then use the square bracket, I. Okay, so as it steps through the for loop, it'll put the variable in there, and do each one at a time. And we'll say output, all caps. Okay, output, close parenthesis, semicolon. Okay, 2 more lines, and then we're done. So I want you to write digital write. Okay, digital write, and then say row pin, and use the square brackets, row pin. So we're stepping through the array and doing this to every single one of them. Okay, we're going to make it low. Okay, so it's low. So that allows whenever we make it an output and we make it low and the colors are high. So if the colors are high and that pin is low, that allows electricity to flow down to it. Okay, so when you have something high voltage, low voltage, there's potential there, and it can have electricity flow. So the colors are going to be set high to be on, and the LEDs are going to be set low to be on, and that creates your flow of electricity. All right, but we don't want to leave it that way, so then we turn it back off again. Okay, so whenever we then switch it back, okay, let's finish this first. So pin mode, and then we're going to say again row pin, row pin, then do your square brackets, have the I in there, just like that. And then we'll say input. All right, close it up, semicolon, and that is done. So basically we activate it and then quickly turn it back off again so that later on we can just turn them on as we need. Okay, so this just gets them ready so we can turn them on and off as needed. Okay, this got all the colors ready, and this got all the LED pins ready. And then what do we have here? This whole thing all the way down to here, all that stuff was our rainbow code that gets it ready to go. That just tests everything. Okay. Now this just turns on the color now. Because our LED is no longer connected to ground, we have to turn on an LED in order for the color to actually flow. We're just turning on and off color, but it won't go through the LED until we turn these on. So we're going to have to modify these to make them work. All right. And so what I'm going to do is add inside of it. I only want to do one LED at a time. Okay. And so we're going to put another for loop inside of this for loop to go through each light. Okay. So here's how we're going to do it. For, then int. We're going to say we're going to go through the rows. So let's just call this row. We can make a variable different. We're going to make it different than I. We're going to call it row because we're going through our rows. We're going to set it equal to 0 because that's the first LED is 0. And then we're going to have it go through all of our rows. So how would we say that? Row is less than, just make spaces there. Row is less than n rows. Oops. Okay. Make sure you capitalize everything properly. N rows, and we say row plus plus, boom. Okay, now we can open curly, and it puts a closed one for us once we hit enter. But let's see, I don't want it there. I want it here. All right, we're gonna stick everything in here. All right, So because we're inside this for loop, we're going to move these over and we're making it proper here. So for int row, going through the rows, what are we going to do? We turn on the color. So we turn on the color, and then when the color is on, let's turn on the LED. So how do we turn on the LED? We say LED on. Which one do we want to turn on? Because remember, when we said LED on, all we need to know is which row. So, hey, we can use that same thing, right? Turn on the row that we indicate, starting with 0. So hopefully this is starting to make sense, okay? Don't forget your semicolon. So we turn on the row, and then we're gonna wait for however long that is, and we can change that up at the top of the program, and then we will turn it back off again, okay? So LED off, and we'll say row. Hopefully this works. Okay, so LED on, LED off. We're just doing one at a time. Now I want this weight to be 1. So I'm gonna go up to the top of the program and I'm gonna change that from 10 to 1 while I'm thinking about it. Where was I? Right here. Okay. So the only thing we did differently was say, okay, we're doing the same color pattern, but we're doing it on one light and then the next light, and then changing. Then we'll go up one intensity, turn on the next one, go up an intensity, do it again, do it again, do it again. Okay. So what you got to do is do that same thing for the rest of these. You got to put this in and the LED on and the LED off for all the rest of these. So I'm going to pause it and do that and then come back and then we'll check it. Okay, so I'm done, but as you can see, I didn't do it perfect as far as like spacing and everything. So, because I want to show you a trick. All right, now if you at least have the right number of curly brackets, as long as you have 2 in each of these, 2, 2, 2, 2, 2, 2, 2, and then the last one has 3 before you get to the void loop, okay? What I want you to do is highlight your entire program and right click and say auto format. That right there will space everything the way it's supposed to be. Goes every time you go deeper into another for loop or something, it tabs over further. Yeah, that way. Anyway, so it tabs over more and everything looks great. And so you can use that auto format to make your life a lot better, okay? And then it just fixes everything, makes it look beautiful. As long as you have the right number of these, okay? If you don't, then it'll give you an error. Let's figure out what's going on as far as verifying and uploading the program. First, I'm going to verify to make sure I don't have any typos. And if I do, it'll let me know and we can work through that together. If you can't figure out your typos, then let me know. I'll come help you out. Or your teacher, whoever it is. And then, oh, I'm good. Okay, so we're going to upload this. And it should go through the whole rainbow sequence fairly quickly because there's only 2 lights. All right. Oh, I forgot to do something that's called going to tools, going to port, and making it the right COM. That's a common mistake that I make and students make all the time. Okay, because this is my first time uploading a program today, and I probably plugged it into a different port. Okay, so let's try again. All right, so, and I didn't put something to block out the light. Hold on. Let me hit the reset button. Only one light is working, so something is wrong. I'm going to figure it out and then let you know what it is. Okay, so I feel like a little bit of an idiot because I wasn't looking at my Arduino very carefully. I think some students played with it during the day. There was an extra wire on there. Anyway, this wire was plugged into number 2, so it didn't even have anything. These wires were all scooted up a little bit and were in the wrong. Everything was just plugged in wrong. The code is great. My wiring was bad. I even had a resistor touching another resistor that was bleeding the colors. And so all sorts of things were going wrong, but I figured them all out. It was just wiring. So I'm not going to go too much more into that, but that's basically what was wrong. So as long as you follow the code that I did, everything should work. And if it's not, most likely it's your wiring, okay? So let me upload it real quick, and so you can see what's going on with it. You'll notice that it'll go through the colors fairly quickly. Because it's going through 2 lights, it's as if the wait time was 2. So, so you can see both of them on there. Now, it looks like they're both on at the same time, going through it at the same time. But watch what happens when I take the wait up to 10. Okay, and I upload that. And you'll be able to, I can't see it with my naked eye, but I noticed that the camera was catching the flicker. The fact that they're only on 1 at a time. Okay, so watch this real quick. As you can see, both lights are flickering back and forth. It's going back and forth. If you can't see it, then just move your head back and forth, but not focus on the lights and just kind of watch them. You'll see a whole bunch of blinks. And that's basically what's going to be happening as we go through the image, blinking each pixel to do an image like this. Okay. Now, as the lights go down and blink, each one of these colors, in the final code, the time for each one of those is going to be even less than 1 on the delay. It's going to be like 0.2, like 200 microseconds, okay? This is gonna be going super fast. We're gonna be running this Arduino full blast, and it's going to be awesome, okay? What we can do is pause it right there because we're already at almost a half hour. So this is the longest video yet, and I'm sorry, but oops, cancel that. What I'm going to do is I'm going to slowly pan through my whole code, and you can pause the video at any point and make sure your code is the same as my code. Remember, you can go File, Preferences, and turn on display line numbers right here. So you can see where you are relative to where I am. I'm zoomed way in so that you can see this even if you're looking at it on a phone. Okay, that's why my text is ginormous here. So line all the way through line 21, I'll scroll down. Here's 22 through 42. Scrolling down, 43 through 63. Scrolling down, 64 through 84. Scrolling down, 85 through 105, 106 through 126, and that's the end. Okay, so hopefully that helps you double check your code. Hopefully you didn't skip to the end and just do that and not pay attention to the video, because the video helps you understand what each of these is doing. this for loop is going through all the intensities, and this for loop is going through each light. So it goes through one light, does the intensity, does the second light, does the same intensity, changes the intensity, does it again. When you have a for loop nested inside of another for loop, it performs this one however many times we told it to. Right now, n rows is 2, so it only does this twice. When we have 8 lights, it'll do this 8 times, and it'll kind of slow down that sequence. It'll be as if we had the wait time for one LED of 8. Okay? Anyway, so if you want to have some fun down here in the void loop, what you can do is turn on a custom color and then turn on a LED, then turn off that LED, just use a delay of 1 for everything. So turn on one LED at a custom color, turn on the next LED at a, turn on and off at a custom color, and then turn on and off the other one at a custom color. And you'll be able to do both lights at different colors using custom color mix. Okay, so using the color mix that we created a while back, you can create something really cool. All right, so we'll call that good. And once you're done with this, then you can actually go ahead and make a couple of custom colors, and then we can turn it in and everything will be good. All right, couldn't resist, so I did it. And here's what mine looks like. So I say color mix, and I say 0 on, delay for 1, 0 off, and then you change the mix and then do LED 1 on, delay, and then 1 off. And then it just cycles over and over again. And you can't really tell on here, but there are 2 separate colors. One is green, the other one is blue. Okay, so try doing something like that. And in all reality, the 2 lights are not on at the same time, even though it looks as if they're on at the same time. And if you remember what this is called, hopefully I told you before, but this is called multiplexing, where both of them share the colors, but yet the color is changing back and forth while the lights take turns being on. Okay, your TV works this way, and all sorts of things work this way, where all the pixels are controlled at different times so that it doesn't have to have a wire for every single pixel separately, wired in color and in whether it's on or off. So look up multiplexing and see how that works. Google it, because I'm going to expect you to know what that word means.